Hi and welcome to Calculus 30 with Miss Verity. Today we're going to be looking at 4.8, the chain rule. So if f of x and g of x are differentiable equations, and if f of x is equal to f of g of x, so remember that open circle means f of g, then f prime of x is equal to f prime of your g of x times your g prime of x. So that looks super complicated, but it's a good thing to know for when you're given charts and stuff to solve different equations. We'll have an example of that at the end. But another way to think of it is if y is equal to a times u to the power of n, where u is a function of x, then our derivative, our dy dx, is going to be a times our power, or a times n, u, so whatever stuff's in the brackets, our power decreases by 1 times the derivative of whatever u is. So what does that look like? Well, if we're looking at example A, we want to think to ourselves, what number is really sitting out front? Well, there's a 1, so it's 1 times 3x plus 4 cubed. So when we do this, our derivative, we multiply our power by the coefficient that's out front. So in this case, we're going to have 3. We leave our stuff on the inside, that stays the same. Our power decreases by 1 times the derivative of the inside stuff. So the derivative of 3x plus 4 is 3. And now we're just going to simplify. So because we've got coefficients and we want to leave it as factored as possible. So we're just going to go 3 times 3, that's 9. That times x plus 4, all of that squared. So that is what the chain rule looks like. So second example, again, there's a 1 sitting out front. So in this case, we're going to have y prime, or maybe dy dx, is equal to, well, 4 times 1 is 4. We leave the stuff on the inside. We decrease our power by 1 times the derivative of the inside stuff. So 2x minus 1. And so in this case, that would be our answer. We want to leave it as factored as possible. We don't have any common factors within there. So that's where we're going to leave it. Our next one, 3x minus 4 squared. Again, so multiply our coefficient up front. So we're going to have 3x minus 4 times 3. We're just going to simplify our coefficients. So 6 times 3x minus 4. Again, want to leave that as factored as possible. For example, D. So again, multiply our coefficient out front by our power is equal to negative 20, 2 minus 3x cubed times the derivative of the inside stuff. So derivative of the inside is negative 3. So we're going to have 60, 2 minus 3x cubed. Ooh, so our next one. First thing, do you like the look? I'm going to say no. We typically want everything to be in powers. So what our function really is, so notice I'm rewriting f of x because I haven't taken the derivative yet. Any radical is just a fractional power. So 2x squared minus 3x to the power of 1/3. 1/3 because it had an index of 3. All right, so now when we take the derivative, so our power times our coefficient, which was 1, so 1/3. Our inside stuff stays the same. We decrease our power by 1, so 1/3 subtract 1 is 1/3 subtract 3 over 3. So negative 2/3. And times the derivative of our inside stuff. So 4x minus 3. And again, we want to leave everything as factored as possible, so that's going to be our final answer. All right, so f of x is equal to negative 3 over 5 times 2x squared minus the root of 5, all that cubed. Personally, again, I don't like the look, so I'm going to change that. So I'm going to have 2x squared minus 5 to the, well, actually, you know what? Just kidding. I do like the look. Root of 5 is just a number. There's no variable with it, so I'm actually not going to change it. So our derivative, we've got negative 3 over 5 times 3. If you remember, negative 3 over 5, when you multiply fractions, it's top with top, bottom with bottom. So negative 9 over 5, also we would reduce if possible, but we can't. 2x squared minus the root of 5 squared times the derivative of the inside stuff is 4x. You can always rewrite it, so I might write it as negative 36 over, 9 times 4 is 36. Yeah, negative 36 over 5x, 2x squared minus the root of 5 squared. So that's our most factored form. We don't have any common factors, so we can leave it as such. So is this the chain rule? We kind of want to ask ourselves, do we have a coefficient out front? And then do we have some type of function within a function? Well, in this case, this function is really just 1/6 times x minus 4x squared cubed. So yes, that is indeed the chain rule. Our next one, well, looking at that, this one is actually not a chain rule, or a chain rule. The reason being because we have negative 2x times x squared minus 3x cubed. This is a product rule. That's what that is. So this, you could not use the chain rule in order to simplify that expression because we are multiplying 2x by the other function. So determine the derivative and factor completely, and then determine what x values f of x has a tangent line so that the slope is 0. So where your slope is 0, those are called critical points. So to figure out where our slope is 0, well, to find out where our slope is, we need to take the derivative. So f prime of x is equal to 3 2x squared minus 4x squared times, this is going to be 4x minus 4. There's our factors. Well, to find those critical points, we want to set our derivative equal to 0. So 3 2x squared minus 4x squared times 4x minus 4. Well, when we've got something completely factored and we set it equal to 0, then we just set each of our factors equal to 0. Well, 3 will never equal 0, so it's not a factor. So then we have 0 equals 2x squared minus 4x. All of that is squared. And we've got 0 is equal to 4x minus 4. I'm going to start on this one just because it's the easiest. And when we divide by 4, we're going to have 1 is equal to x. So there's one of our solutions. On our other side, we are going to take the square root of both sides. So 0 is equal to 2x squared minus 4x. Well, at this point, we want to take out a common factor. I guess I could have also taken out a common factor of 2, but, you know, that's fine. And set each of those pieces equal to 0. So we've got x is equal to 0 as one factor, and now 2 is equal to x. Therefore, we've got 3 spots where our derivative goes to 0, or 3 critical points. So that happens at 0, 1, and 2. So determine the derivative of, well, our first one. So again, if I want to change the look, because I've got a radical, I've got 2 times 2x minus 1 to the 1/2. So when I take my derivative, 2 times 1/2 is 1, 2x minus 1, and then 1/2 subtract 1 is 1/2 subtract 2 over 2. So negative 1/2 times the derivative of our inside stuff, which is 2. So in this case, we've got 2x minus 1 to the negative 1/2. On our next one, well, based off of what we know so far that we've done of derivatives, we actually cannot do this one. So this one, again, is actually a product rule, and so we can't take the derivative of that one just yet. So use the table of values for f, g, f prime, and g prime to determine the following. So there's our table of values. So if f of x is equal to f times g of x, determine the derivative at 5. Well, f times g of x, that is our product rule. So our product rule, we're going to have the derivative of the first times the second plus the derivative of the second times the first. So now that we've got our derivatives, we can use those values at 5. So we are going to have f prime of 5 times g of 5 plus g prime of 5 times f of 5. Well, if we use our table of values, so our first thing, I'm going to move up here, our f prime of 5. So all of these values are at 5. That means we're using only that row. So f prime of 5 is 7. So our f prime of 5 can be replaced with 7. Our g of 5 is 9 plus our g prime of 5 and our f of 5. So we're going to have 63 plus 30, so that is equal to 93. I'm going to erase this just so I can use it for the next one. So our next one, we've got f of x over g of x. Well, that's our quotient rule. So our quotient rule is the derivative of the first, so derivative of f of x times g of x minus g prime of x times f of x all over g of x squared. So the second step I did in the first one, you don't necessarily need as long as you know where to look. So we're looking at 3. So f prime of 3 is 8. Our g of 3 is 6 minus our g prime of 3, which is 4, times our f of 3, which is 5, all over our g of 3, which is 6, squared. So now if we simplify that one, 6 times 8 is 48 minus 20 all over 36. So we've got 28 over 36, which if we look at common factor, probably the largest one is 4. So 7 over 9. Our next one, we have f of g of x. So remember, that can be represented either that way or that way. And so we want to determine f prime of 4. So remember, back on the very first slide, the very first thing we did is we had f prime is equal to f prime of g of x times g prime of x. So this is just like sort of the chapter 10, I think it was, we did in pre-calc 30. So we want to start on the inside piece, that g of x. So I'm going to go sideways, hopefully we can keep track. Well, we're doing it at 4 to start off with. So we're going to have f prime. Well, g of x at 4 is 3. So in our brackets, we're having g of 4 times g prime of 4. If I'm going to swoopity swoop that down there, g of 4, so g of 4 is 3. So now we're going to have f prime of 3 times our g prime of 4. Well, g prime of 4 is 2. And so now to finish this off, we need to figure out where f prime of 3 is. Well, f prime of 3 is 8. So 8 times 2 is going to be 16. So that's what our f prime of 4 is equal to, is 16. So our next one, we have g of f of x at f prime of 5. So f prime of 5 is equal to g prime of our f of x times our f prime of x. So now I'm going to switch to my blue marker. Hopefully, ooh, you know what? I'm going to go red just because it's not up there. So we want now, if I'm going to fill in these values, g prime f of 5, because we're doing it at 5, times f prime of 5. Well, f of 5 is 3. So g prime of 3, because f of 5 is equal to 3. We saw that up there. Times our f prime of 5, which is 7. And then our g prime of 3. G prime of 3 is 4. 4 times 7 is 28. And so that's how you do those ones.